right, so we're moving on to the next lesson. On this lesson, we are going to be finding, oh, I didn't pull up, oh, there it is. We're going to be graphing rational functions, but we're going to have what we call holes, okay? So here, it has a little chart for you to follow along in case you don't remember how to work out the problems or where to start. It goes step by step. So if we are looking here, we have a removable discontinuity. Okay, that's the fancy way to say a hole. Removable discontinuity. All right. Go ahead and highlight here. Is a point on the graph that is undefined or does not fit the rest of the graph. There's a gap at the location when we look at the graph. When graphed, a removable discontinuity is marked by an open circle on the graph at the point where the graph is undefined. Okay, so we're gonna follow similar steps. You're gonna factor all the parts, okay? And so here's a part that's different than what we're used to. So after we factor all the parts, okay, we look, and then here, we find the domain just like we would with any of the other ones. We go ahead and set the denominator equal to 0 and solve for x, and you have here x is equal to -3, x is equal to 3, so your domain can't equal those two numbers, okay? Then from there, you're going to identify the holes and the asymptotes, okay? So if you notice here, on here, we have an x plus 3 on the top and an x plus 3 on the bottom. That causes it to cancel, okay? So when it does cancel, the factor that cancels, that is where you get your hole from. So what you go ahead and do is you set it equal to 0 and solve for x. But then your hole is at a location, okay? Not only does it have an x value, but it should also have a y value as well. So to find that y value, you have to substitute the -3 in the reduced function. Okay, your reduced function is this section right here, the part that does not cancel. That is considered the reduced function. Okay, then your vertical asymptotes would be the factor that does not cancel, which is the x minus 3. And remember, your vertical asymptote is going to be x equals or y equals a number. Okay, then once you do that, you identify your horizontal asymptote based off of the first one. Now remember, you look at the highest exponents, and so both of them are x squared. That means that your degrees are equal. So in order to find the equation of the horizontal asymptote, we have to look at the leading coefficients, which are the numbers here in the front. So once again, if you forget, we set this all up right here for you to remember. If the degrees are equal, then you're going to have to look at the coefficients. If it is less than, then you're going to have a y equals 0. And if it is greater than, then that means you have no horizontal asymptotes. Moving on. To find the x-intercept and the y-intercepts, the only thing that's different with this is for the x-intercept, you will have to use the reduced function. You can't use the mu function. Same thing with the y-intercept. When you're finding the y-intercept, you do have to use a reduced function for that one. Okay, where you plug in 0 instead of x, and then you simplify it. Okay, then you find a few more points and you graph it. So let's get into the problems. So here we got all this already. So our first step is to factor. So I'm going to go ahead and factor the top. Now remember, when I'm factoring, I need to multiply. Since I have this 2 in the front, I'm going to multiply 2 times -2, and that gives me -4. So now I'm looking for two numbers that multiply to give me -4, but we'll add up to -3. So we have 2x squared minus 4x plus 1x. We go ahead and interchange those two. Okay, so instead of having -4x plus 1x, they have here -3x. So we're just factoring, okay? I'm just factoring right now. So I'm going to go ahead and group the first two, and I group the last two. So when I group the first two, I can take out a 2 and an x, and I'm left with x minus 2 times 2 gives me that 4, and then plus the 1x minus 2, I cannot factor that. It's going to stay like that. Okay, so then one more step to factor the top. They both have an x minus 2 in common. That's what I take out, and I'm left with 2x plus 1. Okay, because remember, if there's no number here in the front, there it is a 1. Okay. On the denominator, This one's a little bit more simple. We have x squared minus 2, so we're looking for two numbers that multiply to negative 2, but we'll add up to negative 1. So x times x gives me x squared. 2 times 2 gives me 4. Oh, I'm not looking for 4. 1. 2 times 1 gives me 2. One of them needs to be negative because it is a negative 2 and needs to add up to negative 1. So the negative 2 is going to be negative and the other one will be positive. All right, so remember for your domain, we set these two equal to 0. You set your denominator equal to 0 and solve for x. So that's what I'm going to do here. I have x minus 2 equal to 0 and x plus 1 equal to 0, and I solve for x. So plus 2, x equals 2. Minus 1, x equals negative 1. Okay, so remember when I do my domain, it's going to go from negative infinity all the way up to negative 1. We're going to hit negative 1 first before we go. And then it'll be u. And then from negative 1 to 2. And then another u. And then it's going to continue from 2 all the way up to infinity. Okay. Then from there, if I look, these two cancel each other out. So that means that's where my whole is going to be. Okay. That term right there, they canceled out. This one right here. That's the one that I have to set equal to 0 and solve for x. So x minus 2 equals 0. So plus 2, and x equals 2. So that's my value, my x value. My y value, to find my y value, I am going to plug in, instead of x, I'm going to plug in 2, but I'm going to plug it into my reduced function, okay? So this section right here is my reduced function, okay? Reduced function. Okay, so then I am going to plug it in, instead of x, I'm going to plug in a 2. So 2 times 2 plus 1 divided by 2 plus 1. Okay, once I plug in this 2 that I got for my x in there, I'm going to go ahead and solve for it. So 2 times 2 is 4, plus 1 is 5, and then 5 over 3. So the coordinate of this point, or my whole, is going to be 2, comma, and then 5 over 3 is going to be 1.67. Okay, so now I have my whole. Okay, remember our whole was the one term that canceled, and my vertical asymptote is going to be the other one that did not cancel. So one that did not cancel was the x plus 1. When we set that equal to 0, we subtract 1, we get x equals negative 1. Now this one is not a coordinate, this is a vertical line, an invisible line. Now for a horizontal asymptote. When we're doing our horizontal asymptote, we're going to look at a regular function. So here, the exponent is 2, here the exponent is 2. So my degree are both 2. Okay, if 2 equals to 2, then we're going to have to look at the leading coefficients. So my horizontal asymptote is going to be y equals 2 over 1, which is just 2. Okay, then from there, we're going to go ahead and find our x-intercept. So remember our x-intercept, we have to set the numerator of the reduced function. So the 2x plus 1, we set that equal to 0, and we solve for x. So minus 1, 2x equals negative 1. We divide by 2, and we get x equals negative 1/2. So then the location of our x-intercept is going to be negative 1/2, comma 0. Okay. And then lastly, my y-intercept, we also use our reduced function. So instead of x, we're going to plug in 0. So f of 0 equals 2 times 0 plus 1 over 0 plus 1. Okay. Now 2 times 0 is just 0 plus 1, and then we have 1/2. Okay, so the location of our y-intercept is 0, comma 1/2. All right, so now we're ready to graph our function. So on here, we have our hole. So I'm going to put a hole at 2, 1.67. So 1, 2, and 1.67 would be about right here. Okay, I'm going to make an open circle. That came out a little too big. It was a little exaggerating, but that's where it would be. And then our vertical asymptote is at x equals -1, so right here. And then we have a horizontal asymptote at y equals 2, so 1, 2. Okay. Then we have an x-intercept at -1/2, 0, so it'll be right here. And then we have a y-intercept at 0 and 1/2. So as I can see, my graph is going to come straight up this way, and it's going to cross through here. It's going to come to my hole, but it's going to be like a little gap, and that'll follow across my asymptote. And then if you're not sure, oh, I can't. And then this one will be on this opposite side. I don't know why the arrows don't want to come out there. All right. Scrolling down. So I'm going to do the same thing that I did on the last assignment. I'm going to go ahead and do a delta math problem instead of the example that they gave us on here. That way you guys can practice, or I can show you again how this needs to go onto your delta math. Okay, so I'm going to go ahead and split screen. Okay, now this lesson is graphing rational functions with holes. Okay, so here I have 4x plus 12 in the numerator. So I'm going to go ahead and erase this one. We have 4x plus 12. And in the denominator, we have x squared minus 9. Okay. All right, so our first step, remember, is always to factor. So between the 4 and the 12, we can factor out a 4, and we are left with x plus 4 times 3 is 12. On the denominator, this is going to be one of our special cases, because x times x gives us x squared, and 3 times 3 gives us 9. One of them is going to be minus, the other one's going to be plus. And so the denominator, we're going to go ahead and set that equal to 0. Okay, that's how we start off our domain. So x minus 3 equals 0. X plus 3 equals 0. We solve for x, so plus 3, x equals 3. Here, minus 3, x equals -3. Okay, then from there, we are going to, let's see, write our domain. So it goes from -infinity. First, it's going to hit -3. And then we put the little u. Then we have a little gap. And then we have from -3 to 3, we're going to have another section of our graph. Then we put a little u. And then from +3 to infinity. All right. So then the whole. So if we look and notice that the x plus 3's cancel each other out, then our whole is at x plus 3. So we set that equal to 0, and we solve for x. So minus 3, x equals -3. Okay. And then from there, once we find the x value, remember your whole, there has to be a y value as well, because it's a location, it's a coordinate of a point. So we're going to go ahead, and our reduced function is going to be whatever is left over. So it is 4 over x minus 3. This is our reduced function. I'm going to put an RF for reduced function. Okay, so I'm going to take this -3. So y equals, that's how I'm going to get my y value. And then it'll be 4 over -3 minus 3, which would be -4 over 6. Okay, so the coordinate of this point is going to be, our x value is -3, and then -4 over 6 as a decimal is -0.67. Okay, if you wanted to go, you can also graph it, but I'm going to graph it on delta math. So on the next part, we have a vertical asymptote. So my vertical asymptote is a term that did not cancel out. So the term that didn't cancel out was the x minus 3. We set that equal to 0 and solve for x. So plus 3 plus 3, x equals 3. Okay. Then our horizontal asymptote, we look at the degree of the numerator. So the degree of the numerator is 1. The degree of the denominator is 2. So 1 is less than 2. So that means that we have a horizontal asymptote at y equals 0. Okay. Now, on this one, for the x-intercept, we set the numerator equal to 0 and solve for x. Well, the numerator, all there is right there is a 4. And when we set it equal to 0, well, there's no x's to solve for. So for x-intercept, we have none. And then lastly, our y-intercept, when we're looking for our y-intercept, we plug in into our reduced function. Instead of x, we plug in a 0. So it is going to be 4 divided by, and you plug it into your reduced function. So 0 minus 3. So that would give us 4 over 3, and it's negative, which would give us our location of our y-intercept would be 0, comma, negative 1.3. We have 3 repeats. Okay, so let's go ahead and graph that on our delta math. So if we look here, let's start off with our vertical asymptote. We said our vertical asymptote was at x equals 3. Okay, so here I'm going to go ahead and drag this all the way to 3, and it's a positive 3. My horizontal asymptote, we said it was at y equals 0, so I'm going to drag that down to 0. My x-intercept, we don't have one, so I'm going to go ahead and skip that. Oh, let me unclick it, because do you see how I clicked it and it appeared right here? So I need to unclick it. There's no x-intercept. My y-intercept, we said, was 0 and negative 1.3. So it's going to be somewhere down here. And my whole, I said, was going to be negative 3 and negative 0.67. So it'll be, oh, let me go ahead and drag it. It'll be somewhere right here, I believe. Wait a second. Oh, yeah. You know what I have wrong? I have this one wrong. It's negative 1.3. So it needs to be between negative 1 and 2. Okay. And we plot the rational function. It comes out. I'm going to move this just a tiny bit because it doesn't go through it. Okay. Rational function. Well, that's as good as it's going to get. Are you sure? Yes. And that's it. Thank you guys. We'll see you guys next time. Bye.